Welcome to everyone. I think it's time to start. First, we are going to record this webinar. Welcome to our webinar training from bigger to better, how Vishay, eSMP and DFN packages drive automotive downsizing. My name is Thomas Bolz. I'm the product manager from Rutronik for standard products. Today's webinar is entitled From Bigger to Better, how Vishay, eSMP and DFN drive automotive downsizing. You learn how Vishay latest eSMP and DFN diode packages enable higher power density, improved heat dissipation, and long-time reliability in space-constrained automotive design. Therefore, Vishay and Rutronik makes a webinar on this issue. Our presenter is Richard Netham and Teshawara. Hello, Richard. Hello, Teshawara.
Hello.
Thank you for your time today. So, will you introduce yourself?
Yes. Welcome. My name is Richard Needham. I work for Vishay Semiconductors. I'm the Regional Marketing Director for Europe for the Diodes Division, based in Heilbronn here in Germany.
And so, Teshawara, will you introduce yourself?
Yeah. Hi, my name is Tejeshwara Manjunath. I work for Vishay Semiconductors as well, together with Richard based in Heilbronn. I work as an Automotive Market Development Manager from Diodes Division.
Okay, some issues to the questions. If you have any questions, please use the chat window on the side. We will answer the questions at the end of this training. If you have any more questions later, you can contact us personally or via email. The presentation itself will be recorded and will be available online afterwards. So this is all from my side. So please, will you take over first, Richard? Thank you.
Thank you, Thomas, and thank you to Rutronik for this opportunity today to present our latest technologies in the Diodes division, specifically in the automotive market. So the agenda, what you see here is now the agenda for the presentation. I'd like to give just a short introduction of who Vishay Diodes are, and why we are the market and technology leaders, for the Diodes products. And then I'll hand it over to Tej, who will then take you through some basics and life cycle information about the Diodes products. Then specifically focusing on a key part of today's presentation will be on the latest the packages, the packaging that we use for the full portfolio of Diodes products that we have. We'll then move to specific automotive trends and applications. So specifically, there's a lot going on in the automotive market that is driving the need for these new technologies for downsizing and for greater performance. Then finally, we'll then bring it back up a level to kind of like to some solutions and new products. So taking some examples, some application examples, and which of the latest Vishay products will fit into that, and then summary at the end. So what I'd like to do now is go through from the factories. What you see here is we are a global company. It's obviously a global industry, and this has been built up over many years. Vishay has made a few acquisitions in the last 25-30 years. What you see here on the headquarters of the Diodes division is in Taiwan, Taipei, and there we have one of our 200mm factories, wafer fabs. The wafer fabs you can see in blue, but also we have a strong presence in Europe. So you can see there another 200mm factory in Borgaro in Italy, Heilbronn, where we mentioned we're from. We've also got a factory there, and Vöcklabruck in Austria as well. And then what you can also see is the UK Newport. It's a later acquisition, an acquisition that we made the site from Nexperia with the previous owner. Due to some geopolitical issues that they had, they were obliged to sell that, and we bought that from them in the UK a couple of years ago. That's primarily for MOSFETs, but also it will be used for diodes as well. And then you can see from the yellow, the back end, so the test and assembly, the back end, these are the facilities, the Vishay facilities, in-house owned facilities that we have and put together. So you can see here, there's a huge footprint and strength in Europe. Vishay is very much a European company as well as being a global. And then as we talk about automotive trends and the importance of automotive, is clearly a key part of the European landscape. Has been in the past and will continue to be in the future. So that gives you I think we're roughly about $600 million of revenue. About a third of it's in Europe, so a significant chunk of our revenue is in Europe, and about 60%, over half of our revenue is actually with automotive products. So automotive is by far the largest segment for diodes. So and that's probably enough. I'll get a general introduction about Vishay Diodes products. What I'll now do is hand it over to Tej to take through from the basics. Yeah.
Okay. Thank you, Richard. So, I mean, I wanted to start with the basics of diodes. I'm sure you would already know it, but just a quick brief what is important with respect to the next. So going through it is, I mean, it is the simplest electronic element which you have. It has the positive element anode and the negative element cathode. Apparently, it is with respect to the PN junction. Apparently, we have some issues with respect to the animation, but I'll try to make it through. The diode itself has a PN junction inside it, where two different layers made of silicon, and then it is trying to block the current with respect to with its flow. It's like a switch on, and then it will flow. We have certain characteristics which is very important in diodes. We'll just run through by it. Forward voltage, that is the current is flowing from the positive to the negative. Here you can see with the animation also with respect to the indication of voltage, and the other way around with respect to reverse voltage from coming from the negative side to the positive, where negative voltage will be trying to run through the switch. The breakdown voltage is the voltage where the diode breaks its function so that the current can run through from the negative to the positive. And where the other characteristic is the capacitance, where in the switch there is certain level of capacitance due to its properties, which is an important characteristics when you want to use it. Coming to the next factor is the leakage current, which might play a role when you design an electronic board. So that means the leakage current is a small amount of current which is leaking through the switch when it is still not open or break down. And another two important factors important for the diodes is the reverse recovery charge. That is the charging which happens when the switch opens up, and then the discharging time, which is very important, which acts like a switch. So that is the reverse recovery time when it switches back to its original position. So these are the important features with respect to diodes when you have to consider. There is a very informative video from our colleague here from Heilbronn, so I have put a link on it. Maybe in the future or when you want to know more, then you can please use it. It is very good. Coming to the next one is with respect to the PN junction. As you can see, the silicon formation. So with the diodes, it is divided into many versions of it. The easiest version, which is commonly used for AC to DC conversion, is the rectifier diodes. One factor with respect to the switching on and off is where the differentiation happens. The ultra-fast diodes are the diodes which switches fast back. That means they have charging time which is very less. Whereas there's a Schottky diode where there is a metal junction in between the PN areas, which results in very low forward voltages and very fast switching speed, faster than usually than the rectifier diodes. Coming to below the rectifier diodes is the small signal diodes. That means they are less than 1 amp. They're very small, used for only limited or for a small power applications. This is called signal and switching diodes, very small, used for fast switching applications. There's also a Zener diode designed to operate in reverse breakdown for voltage stabilization, which is very common diode which is being used. And as you can see, even from the symbols, the direction is from the cathode towards the anode, where the functionality is being used. Coming to the protection diodes, those are the TVS, transient voltage suppressions. When you have some peaks of transient voltages, you need to protect the circuits. So this is why the TVS diodes play an important role in it. And then the ESD diodes, designed to protect electronic circuits with electrostatic discharges. That's also frequent. There are many examples with respect to the need of ESD diodes. These are some of the basics with respect to the diodes. Going further with respect to the next slide, where we will know about the life cycle of diode itself. with respect to the life cycle, the focus of diodes, if you remember Moore's law from the last century, where he said every now and then, every 2 years, the semiconductor parts will double and then the size decreases. Based on the same line, the focus also from diodes and with respect to Vishay is also on the same direction, where the focus is mainly on the being fast, being efficient, and being small. This is the basic of it. And based on these, we have based on these factors, we have the bell curve, which is defined based on the packages. As you can see, the nice bell curve where on the right side is the declining packages. In the middle is the growth and maturity, and then on the left side is developing and emerging packages. From Vishay's side, we are mostly focused on the growth side, that is the left half of the bell curve, while the right side is more on the mature and declining packages. Our focus from Vishay is also being on the powerful side. That is why the focus is on the DFN packages, eSMP, and also the flat pack. DFN is flat, dual flat, no leads, whereas eSMP is the enhanced surface mount power packages. So when I say it is the growth packages, let us tell you what from Vishay perspective growth, maturity, and decline is. When you see in the next slide, where you will understand the growth from Vishay perspective, it's a new technology where there is a lot of investment in the manufacturing. The eSMP and DFN packages are available, which is readily available in a sense. There is an investment with respect to the capacity where 8-inch wafers for Schottky and ultra rectifiers are present. And also for Vishay's own, as Richard said before, with respect to Newport, we have also a small role to play from diodes division with respect to silicon carbide, where its own design and manufacturing is the focus. Whereas coming to the middle part of maturity, where it's an old technology, but still relevant. This is where we make selective investments only based on the need and the business cases. It is being mostly outsourced to support capacity issues and capacity flexibility, defending existing shares and being more opportunistic growth. So this is where the mature products, and I think the packages where like SMA, SMB, the standard industry products which are there. So this is the mature products. Coming to the other line with respect to declining, I think these products are there since my existence on planet Earth, so but still relevant and still being used. So these are like obsolete technology, majorly outsourced, and then there might be an issue with respect to supply chain management. I think with the current trend, it might also be a case. And we do not recommend this obsolete technology for the new designs. That is one of the criteria where we say these are the focus from Vishay. Going to the next slide where we will understand the packages itself. So Vishay diode packages has this industry packages. I think you've all seen a lot of these packages on the top side where SMA, SMB, SMC are there. Even the DPAC for high power, smaller the size, smaller the power. Simple logic with respect to bigger the size, then bigger the power in that sense, where the focus from Vishay is to have this eSMP series and the flat pack series, where it is being distributed between multiple of varieties of packages which will fit into your needs. You are not like obliged to take one, whichever which fits. That means you have the power to have different choices. For one example where you have this asymmetrical and symmetrical. Asymmetrical is something where you have better thermal performance, whereas with symmetrical you have better current capacity. So based on your application, you can also choose for the same power. But why is Vishay interested in eSMP? So there are certain features which we think would help you as customers or as designers. We can see in the next slide one example of the SMB. On the left side, where we have SMP, Slim SMAW, and Slim SMA as 3 different versions. The features or the positives of choosing these is with respect to the height. I mean, height is one factor. As I said, Moore's law, everything is being shrinking down. Downsizing, which is an important trend as well. So on the height, if you can see, SMB is the tallest, whereas you can compare the eSMP products, they are comparatively very small. Going also with respect to footprint, the SMP is the smallest, whereas the others are comparable with respect to, but still smaller than the SMB. The surge power is where the criteria or the more positive thing is that even with the smaller size, we have packed from Vishay this same surge power with respect to the TVS diode, which you can still use. And to be honest, Vishay has one of the broadest ranges of eSMP packages which you can find. So you have more flexibility with respect to the eSMP products. Going to the next slide, where we have the features, where, as I said, explained just once again, the features with respect to space-saving packages, excellent heat dissipation, low device height, low thermal resistance, and obviously automotive qualified. In the eSMP series, we have diodes in rectifiers, protection diodes, and then also small signals in all the different kinds of diodes. We have the eSMP packages, whereas flat pack packages, which is a bigger one, we have in rectifiers and protection diode of TVS. As I said, Vishay is setting new industry standards for surface mount packages. It is also on the similar lines that we go to the next slide, where we can define what is the factor with respect to DFN series, power DFN. So on the same lines where we've gone through an example of why the need of eSMP is, even with respect to the DFN series, it's on the similar lines. As you can see, we have three different varieties, versions of DFN, DFN 3820, DFN 33, and DFN 6545, with respect to the high power and also the size. We will see in the next slide the same example where we go through the SMB factors. We came into the eSMB, and then why is there a need with respect to DFN? For the SMB factors, we will take on the similar lines the power DFN 3820. 3820 is just telling you the factor of the length and breadth of the DFN diode itself, 3.8, and then 2.0 as the length and breadth of the chip itself. So very, very small. I am sure you will not be able to see it because it's just like a dot in this one. So maybe we can add a picture later on with respect to just to show you just how small and tiny it is. So the challenges are already bigger. So, but the features are very well. So as you have seen with respect to SMB, which is the standard, when the goal is the downsizing, you can see the DFN package is also similar, very small with respect to footprint. The height is also very small and similar to the eSMP packages comparatively. But the important factor, which is the highlight, is also the current rating. If you can see the current rating of the DFN packages as shown, it is in par with respect to the SMB packages, delivering you a lot of positives. One more important factor is for the manufacturing efficiency, and then for the soldering factor, where the DFN packages is sidewall plated always with respect to DFN 3820, helping you in AOI compatibility. That means you don't have to do extra quality checks or any other things because it is being taken care from automotive optical inspection. So automated optical inspection is the word. So these are all the positives with respect to DFN. Going into the next slide, where we have of all the three, it has been released. Just for your just for your references, we have for current rating less than 10 amps and then power ratings of 600 watts. We have DFN 3820 as the selection factor. For higher than 10 amps and 3K watts, you have DFN 6546. And then for being competitive with respect to our competitors, where you have QFN 3x3 as one of the factors. So we have DFN 33 amp. It is like a square package with 3x3 millimeter size. So going further with respect to the next positives, as I've mentioned, we have power DFN in protection diode, which is TVS, and rectifiers. All kind of rectifiers now are released. Some of them are still in development, so you definitely will have choices. And then, as I said, with the features, which makes it prominent with respect to being used from designers and everyone, the fulfilling AOI requirement, enhanced current and power ratings, similar to the old packages, but smaller, low thermal resistance, low profile, light, compatible LAN patterns, and also automotive qualified. This is all with respect to the power DFN, where high power and then high current is being used. But please don't forget, as we did in the basic, there's also a lot of small signal diodes, where we also have small signal diodes in DFN series, where we have the protection diode of ESD and also small signal diodes in variety. Can we go to the next slide? I'm not sure whether
We should try. See if it's going to work.
This presentation introduces an application note on soldering recommendations for power DFN packages. In order to support customers' downsizing programs in many applications, such as automotive, industrial, and telecom, Vishay offers the new Power DFN series in leadless packages, which help to maximize board space, enhance thermal performance, and fulfill automated optical inspection (AOI) requirements. This presentation also explains PCB solder mask design types and general stencil screening rules, as well as the recommended solder paste and reflow soldering process. The actual AOI capable performance with actual images of DFN 33A and DFN 3820A after reflow soldering are also included. The solderable area of the center pad, as defined by the solder mask, SMD or NSMD, should match the size of the E-pad of the component. The PCB solder LAN design selection is made based on the design rule applied by the customer. Depending on the customer's application, components of different sizes can require more or less solder paste. The stencil thickness may vary. According to the stencil thickness that the user will use, the stencil opening has to be adjusted to use the recommended amount of solder paste. In order to apply an accurate amount of solder paste onto the PCB, laser cut openings with plasma treatment for good release of the solder paste are important features of the stencil. With a proper PCB footprint design, extended on both sides, and right amount of solder paste, a homogeneous solder meniscus will be formed after reflow soldering.
So if we go through to the next slide.
Yeah.
Okay. Thank you, Tej.
Sorry, we will provide the video link later on. You can also find it on Vishay website. Going to the next small signal diodes, which I've said about. So the small signal diodes, as you know, there's industry standard package. SOD is 523 is one of the known packages where it is bigger. There's also SOD 123, which is also a bigger size. Based on both of them, you have a DFN 1006. 1006, as mentioned, 1 millimeter to 0.6 millimeter, very, very small with respect to the package itself. So the advantage is with respect to the space, footprint, and also the height. There's also a very prominent and very popular package, SOT23, and there's also a smaller version of SOT23 in SOT323. So smaller in size, but you can replace both of them with respect to one DFN part number, 1110, which is being shown on the right side. If you can see the size of the SOT23 and also DFN packages. Based on all these, even you also consider that there's an also DFN 1412 under development, which will also can be considered, where you have the power and the size with respect, which you can cater with respect to the existing parts. But the question would be why with respect to change the existing. As I said before, we will show you the features which might be interesting you as a designer in the next slide. Where first of all is the PCB space consumption. As you can see, the footprint, it is a major difference between what you have and then what you could have with respect to DFN. The thermal performance with respect to the function, That means, as you can see in the SOT23, the junction temperature is as high as 80 degrees, whereas with respect to DFN is below 50 degrees. So this is one aspect which will be better, that the heat goes into the PCB itself. So having a positive on the functioning of the diode itself. The third one is the solder performance, whereas you have already known wettable flanks, which is very easy. This is where the AOI capability comes in, where you have reduced quality inspections with respect to this one. So we have the next slide where we were supposed to show the video, but you can also find it on the Vishay website. We can also send you the link later on.
DFN stands for dual flat no leads and describes the package type with electrical contacts on two sides of the package with no exposed leads. The following video shows the difference between a standard SOT23 package and a DFN 1006. 1006 stands for the package length of 1 mm and the package width of 0.6 mm. All the electrical power applied to a TVS, ESD, Zener, switching, Schottky, avalanche, or rectifier diode is usually converted into thermal power, which heats the diode. Due to the shorted pins made of metal with higher thermal conductivity, the thermal resistance of a DFN 1006 is much lower compared to a SOT23 package. In comparison with a SOT23 package, the same chip inside a DFN 1006 package offers a much smaller package size, less space consumption on a PCB, a remarkable lower thermal resistance, a lower package inductance due to shorted leads and bond wire.
Into the next slide with respect to Vishay. So as you already know, Vishay is one-stop shop. With respect to diodes, we have all kinds of diodes, starting from rectifiers, that is with the standard rectifiers, fast, ultra fast, Schottky, and then silicon carbide, and then the bridge diodes which we have. With respect to small signal, we have the Zener, Schottky, and switching, all prominent, which is being used even now. And then from under protection diodes, we have ESD, EMI, and then also the TVS diodes, which is very prominent. And then we are technology leader with respect to the TVS. The next slide is where we will see the automotive trends. There are so many trends, but I have tried to narrow it down to some three in the next slide, where there's only three we have taken. For example, the new trend which has already taken over the overall market globally with respect to the electrification and electrical vehicles. It is also being justified with respect to the number of vehicles being sold every year. I think this year new registrations with respect to new vehicles of EV has been 17 million or something. So the trend has been increasing even with respect to the hybrid vehicles which is being there. So the second one trend which is very important is the software defined vehicles and its connectivity, where with respect to the software you have this new vehicles even in correlation with EV vehicles, where it plays an important role. The autonomous driving, which is being there for a long time, where there are still researches going on, still regulations are going on. We can see in the next slide some of the points which I want to highlight with respect to the trends which is being dealt with automotive. Firstly, with respect to the EV vehicles, the vehicle safety itself, which has been standardized with respect to a lot of airbags, which is already there. But you also have to deal with respect to the high voltage safety, which is very important. The battery systems, which is being new. There are a lot of varieties of solutions which is present, but standardization is something which is going on with respect to EV vehicles. The onboard charging is one factor, and the communication protocols, because there are so many varieties. The standardization is very important. I think the German OEMs and also the Thai ones are working also on the similar directions, where they are collaborating for the first time in the history to go into this software collaborative, that is for the software defined vehicles, where you need a centralized computing. This is one more challenge for the manufacturers with respect to how to compute such amount of data, where you will need high performing processors just to cater to such kind of challenges. You need advanced sensors. You need also the scalable softwares. Maybe some software is limited in some factors where you might have to do software. One of my favorites is the over-the-air updates. So I have also have a car where it says get out of the car, we need to do some updates, so we just leave the car and then all the update happens over the air. So and then some safety and then security systems is one of the important factors where, so for software defined vehicles it is one of the criterias. For autonomous driving, where from parking on its own to having autonomous driving where you don't have to do anything, so the robustness in vehicle connections and also the advanced sensing and recognition is very, very important, not only for the vehicle itself, but for the safety of the drivers and also for the others who are there. That is why the safety systems for driving, brakes and steering, etc. is a very important factor with respect to this one, where even the cybersecurity and standardization and regulation, which I said before, are some of the criterias where the next trends with respect to not only the OEMs and the cars, also the tier ones and also semiconductor manufacturers working on tirelessly with respect to bringing in such features. Going into the next one, based on the same trends, we will like to go through a couple of applications. One application related to the EV vehicles is the traction inverter. Based on the new trends and the new charging capacity and then the need for high power, you can choose varieties of designs. The representation of the block diagram here is a factor, reference factor, just to mention what might be important for such a design. For example, we can use the silicon carbide MOSFET based traction inverters. This is very popular. As you already know, Vishay has also invested a lot of done a lot of investment in Newport with respect to the same line, silicon carbide MOSFETs. We also, as I said before, silicon carbide diodes is also a role to play with respect to this one. There's also one more design with respect to high voltage IGBT based inverters, where the IGBT based inverters are mostly for the 400 to 500 volts battery systems. We're usually working around 600, 650 volts, whereas the silicon carbide is mostly for the 1200 volts switches, where the battery system is on the 800 volts. Based on same lines, the EVs with high power battery voltages for traction and low voltages, which has been existing, you will need an flexible recharging. So there's also the trend of having the charging back to the grid or from grid to the car to the back to the grid. So there are different variations and different varieties. So you need to have that strong design basis. So that's why the protection and the safety operation of the overall system is an important factor to consider for the traction inverters. And also because of the high switching frequency of up to 30 kilohertz is now the state of the art, which was not before. So based on all these challenges which we have with respect to the new trends and designs, Vishay has some solutions with respect to it. The next slide, where we have shown all the diodes, but I have not put all the diodes because then it would be majestically only pictures. But I try to narrow it down to only 2 or 3 pictures, packages, for each function. For example, this one where we need this ultra fast FRET diode technology, which will used for optimizing overall system. The devices offer trade-off speeds for surge capabilities of up to 175 degrees. As you can see, it can be used for DSAT, bootstrap, and also for high frequency low power rectification. There are many packages. I've mentioned some of the standard packages in this one. There's also signal conditioning, as I've said before, the Zener diodes as used as stabilizers to reduce the voltage peaks, ripples, constant voltage to build into a reference voltage sources. So these are some of the packages in SMF because of high power and also in DFN packages. One of the important transients protection for the ICs because of the over voltage due to load switches from the IC and MOSFETs. You need TVS diodes. Here, particularly, we are focusing on X-clamp TVS diodes available for 24 volts, where the peak pulse power from 7 kilovolts to 11 kilovolts can be handled. We have in two packages, DO218AB, the bigger one, and also the SMC packages. I'm not sure whether you will be able to see, but somewhere on this one, the biggest, if you can see the package. So similarly, we have this silicon carbide, which is very efficient with respect to the high switching frequency and also for high temperature compared to the silicon diodes. So we have in 3 standards, which is all available in 3 packages for high powers. We have for the voltage stabilization, which we have spoken about. And the one more thing is with respect to the Schottky diodes in TMBS generation 3, which has very low VF. That means it have negligible switching losses with enabling for high frequency conversions. That means you can use it for polarity protection, which is very common, and also for freewheeling and snubber functions. Last but not least, the ESD protection, which is very important for the communication factors protocols, where LIN, which is being normally used for small functionalities like door opening, whereas with respect to CAN protocols are needed for protection. So we also have in DFN packages. As you can see, the focus from Vishay is also on different DFN packages where needed. Having said that, let me introduce a couple of Vishay new products. First one is in the silicon carbide. We have an automotive grade generation 4 1200 volt silicon carbide Schottky rectifier. As you can see, there are 4 different versions of it. One important factor is the D square pack, where as the power goes, you need to have for safety the creepage distances as well. So the creepage distance is one of the best with respect to 5.4, if I'm not wrong. So this is one of the important factors considering for the high voltage applications, where the application with respect to battery management systems or EVs or even AC-DC power factor conversions or DC-DC conversions. So these are some of the important factors where this new silicon carbide diode is used. It is also being released, if I'm not wrong. So where you have the junction capacitance of to 175 degrees Celsius. Obviously, the positive VF temperature coefficient compared to silicon carbide components is known. So, and then also with respect to superior switching performances. The next one which I want to highlight is the 1200 volts FRET. And that is the new technology with platinum doping, generation 7. This has been one of the important factor or important, I would say, popular one in the new designs, what we are seeing with respect to the OEMs, where the small package, high power, and with all the creepage distance of 3.2 millimeters, it's been very, very popular. The automotive qualified versions we have in 1 amp and 2 amps, where the important highlight with respect to this is the creepage distance and the comparative tracking index CTI, which is greater than 600 volts. That means you have reduced creepage distance because we are using a mole content material group 1, which will give you that flexibility to have the creepage distance smaller. That means you have more robuster part. Having said that, the applications with respect to this one is the AC-DC, DC-DC converters, the bootstrap diodes, desaturation diodes, auxiliary functions just as freewheeling, snubber, high voltage, high frequency rectification. So these are some of the positives with respect to this new diode, which is already being released. The next one with respect to the application itself, I've taken the ADAS, Advanced Driver Assistance Systems. I think in the last decade, you wouldn't have imagined this as one of the important factors. Nowadays, it's just a default one. It is needed for your safety. That means the ADAS constantly monitors your vehicle's surroundings from multiple systems, be it sensors or drivers. That means you need that dynamic and efficient components which will react quicker in a sense, because it is a dynamic environment when you are driving through a road where you do not know any other factors. So use of high frequency technology because of high data, because of radar and lidar, where you can provide collision prevention and also the blind spot detection. I think there's also features of adaptive cruise control. So these challenges where you will need to have diode which will cater to the fast reaction times and also for high data transfers. That is why you need the high reliability of wide range of drivers, where, as I said, lane detection, pedestrian detection, and driver monitoring, where these are some of the factors for ADAS application. From Vishay side, we have many diodes. So in the next slide, we have tried to have it as a function. That means for high frequency rectification, we have Schottky rectifiers in TMBS technology in different packages. For surge protection function, you have TVS diodes. It is one of the reliable for automotive technology, where you have load dump power line protection as well, protecting the sensitive circuitry with respect to the sensing or with respect to the ECU itself. So we also have load switch and polarity protection with respect to the hyperfast rectifiers, and even standard rectifiers can be used. And also with respect to data line protection for high speed data communication, where if something is happening, you need the sensors to send back the control trigger so that the vehicle can be steered or braked or whatever which is needed at that point of time. So Vishay has this, as I said, the package eSMP packages in different varieties. So this is one of the highlights with respect to the Vishay solutions. So one important development I would like to show is in the next slide, where we have the ESD protection diode with high power in DFN package of 1110, where the main application, main intent of developing this product is for the new trends of the SDV vehicles or autonomous vehicles, is the in-vehicle network communication, where there are ESD factors which might affect the circuitry and then obviously damage or the function. So this is where the application of this diode with respect to zonal controls or ECUs or VCUs. So this is where this need developed, where we are developing, which will be released in next quarter. That means the start of next year, where the one important factor is the surge power of 30 watts for an 10 cross 1000 microsecond pulse, which is the standard for ESD diodes. So based on that, and also the immunity of 30 kilowatts, 30 kilovolts is something which is one of the factors considering for these diodes. Going to the last one is the DC-DC converter. I've taken the standard one, where being the 48 volt subsystem is becoming standard now. So where you need flexibility of, as I said, high efficiency and then low losses, obviously, because you will change from the 48 volts to the existing 12 volts battery systems, where you can use a boost or buck converters, trying to achieve that with minimal losses. That is why you need voltage stabilization, and also you need the bidirectional products, where the idea is in in some of the vehicles where EVs considered, you can also charge the higher voltage battery with the lower one whenever it is needed, so that you can compensate with respect to the functioning and also the range extensions. So these are some of the challenges with respect to DC-DC nowadays. Going to the solution from Vishay side, we have a lot of products, as I've already explained. Running through just quickly with respect to this one. So we have said load switch, polarity protection. We have DC-DC conversion, surge protection for TVS. For Zener is similar with respect to this one, and there's also ESD protection, which we spoke about in the previous one, where 30 kilowatts as immunity is very important. One important new development with respect to the TVS is in the next slide, which is catering into the newest trends, what is happening. So this is the bi-directional flat clamping TVS in SMC packages. Application is the automotive, electric vehicles, hybrid systems of 48 volts, the power line surge protection, and also for the other applications needed. But the important factor with respect to this one is it is having a near ideal clamping voltage. That is the blue line which you are seeing. The older TVS, conventional TVS, is where the clamping voltages increases as the current or the temperature increases. As you can see, the increase, whereas with respect to the flat clamping is there, where the clamp happens in an ideal line. So this is more like it is performing in line with respect to the breakdown voltage. That is the clamping voltage ratio, and then the breakdown voltage ratio is almost similar to 1. That means to achieve this, usually in the designs you have to use 2 TVS diodes to cater for it, whereas with this one single one you could also have cost-effective factors where we have 2 chips in one, where you can achieve such a clamping voltage which is constant with higher temperatures. So this is with respect to the new Vishay products, and then with respect to the Vishay solutions for the automotive trends. I would like to also tell you with respect to the latest situations where, due to semiconductor trends, where there is closures, and then where there is need for the crossing list against competitor products. We have already selector guides which is available in our website. There's also some crossing lists which we have developed to cater to the current situation where one of the suppliers is not available. So Vishay is trying from every direction to try to help and support the current situation with different diodes, and also the crossing list which might help you in your present design also for the futures. Coming to the end of it, so I would like to summarize what we have learned. I hope it was helpful. The summary is, we learned about the basics of diode. We learned about the diodes life cycle and packages with respect to eSMP, and then the DFN packages, Vishay's DFN advantages, and also the automotive applications and solutions. I would like to close the session with respect to, if you have miniaturization problem or downsizing, if you want to have a similar package but in a smaller size, and if you need to have the variety of choices in packages, eSMP packages is the right direction. Whereas if you need better thermal performance, and then if the space constraint is needed, and if you have the AOI capability as a must for, then the DFN package is something which you have to look for. So I'd like to close, and then thank you very much.
So thank you, Teshivara. It was a really great presentation, and it is very good explained. And thank you, Richard, for the introduction. And now we are open for answers and discussions with you. So you can start a question, or we can read the question and give answer. And don't forget, if you have any question later, you can contact me, or you can contact us, you can contact Richard, you can contact Teshivara. So don't hesitate if there's any question open. Okay. So I can see no question.
No, there seems to be no questions there at the moment, yeah. So
it was very good explained, so there's no question open.
Yeah, and I would encourage people to take there are links in there as well, particularly the kind of the videos, but also that's available on the website as well. So you'll get it through from Rutronik in terms of the links, yeah, which is important. But also if you can't wait for that, if there are some videos, the diodes and rectifiers section of the website, you'll be able to see them. It's quite well organized. You'll be able to see, talking about DFN, you talk about eSMP, sometimes even kind of the EST protections and Schottky rectifiers as well. So a lot of the key factors that Ted presented today.
Okay, so thank you for the participation. Thank you for the time to make this presentation, and have a nice day.
Thank you, everyone.
Thank you, everyone.
Thank you very much.
Thank you.
Bye-bye.
Ciao.